Today we are exploring a huge shift in the balance of infantry warfare, the Panzerfaust or tank fist. Throughout military history, major breakthroughs usually belong to empires with massive industrial capacities. But in 1942, a team under Dr. Heinrich Langweiler did something radical. They designed a weapon that effectively democratized armor destruction. It stripped away the traditional tactical advantages of the multi-ton main battle tank and put that lethal capability directly into the hands of a single isolated infantryman. This is the story of how chemical energy and recoilless physics changed the battlefield forever. To understand why the Panzerfaust was necessary, we have to go back to 1941 and Operation Barbarossa. The German military advanced eastward, completely confident in their anti-tank doctrine. Then they hit what historians call the T-34 shock. Standard German anti-tank guns of the era, like the 3.7 centimeters and the 5 centimeters Pak-38, relied strictly on kinetic energy. They were essentially trying to throw a high-velocity solid metal dart fast enough to punch a hole through steel, but Soviet engineers had tilted the playing field, literally, by sloping the T-34's armor at a 45-degree angle. They effectively doubled its relative thickness to oncoming horizontal fire. As you can see in the diagram, these high-velocity kinetic rounds would simply lose energy, shatter, or violently deflect off the hull. The infantry was suddenly defenseless against advancing armor unless they happened to have a massive multi-ton artillery piece nearby. They desperately needed a way to abandon kinetic impact entirely. The solution arrived when Dr. Langweiler and Abba's team at Hasag turned away from kinetic energy and embraced chemical energy, utilizing the Munroe-Neumann effect. Instead of relying on the speed of the projectile to breach the tank, the weapon used a warhead packed with a 50-50th mix of TNT and trihexogen, or RDX. Inside the warhead sat a hollow, cone-shaped metal liner made of copper or mild steel. When the nose made contact, a base-mounted fuse triggered a detonation wave from behind. This wave collapsed the cone inward, generating an unimaginable amount of pressure that focused the energy into a hypervelocity jet traveling at 10 kilometers per second. Crucially, this jet isn't molten plasma. It actually remains solid steel or copper, behaving under such extreme pressure that it flows through rolled homogeneous armor like a liquid. It could melt through up to 200 millimeters of steel, but forcing a massive 149 millimeter warhead down a tube creates a massive problem. Physics. Firing a payload that size traditionally generates a violent, shoulder-fracturing recoil. To solve this, the designers looked back to the Davis gun principle. The Panzerfaust is completely open at both ends of its 44-grade steel tube. When the black powder propellant ignites, it pushes the warhead forward, but instead of trapping the expanding gases, an equal mass of fire and gas is vented violently out the open rear. By perfectly balancing these forward and rearward vectors, Newton's third law is neutralized. The weapon has zero recoil. It meant you no longer needed a heavy carriage or a complex hydropneumatic recoil system. A single soldier could comfortably fire an artillery-grade warhead right from their shoulder. As the war progressed, the weapon rapidly evolved. The initial Klein model had a small 100mm warhead, but it was quickly replaced by the definitive Panzerfaust 60, featuring a thicker tube and a heavy 149mm warhead. By late war, the Panzerfaust 100 utilized a two-stage propellant to push its range out to 100 meters. There were even reloadable prototypes like the 150 and 250 models that integrated anti-personnel fragmentation sleeves. The industrial footprint of this weapon was staggering. By the end of the conflict, total wartime production reached approximately 6.7 million units. While the Panzerfaust inverted the tactical calculus of armored warfare, we cannot overlook the sheer terror of using it. This graphic highlights what we call the suicidal geometry of ambush. Because the weapon was unguided and low velocity, its effective engagement ring was a tiny 30 to 60 meters. Think about that. To destroy a tank, an infantryman had to let a multi-ton war machine crawl well within its own machine gun kill zone before taking a shot. Furthermore, the open tube design created a deadly 3-meter backblast cone of fire and smoke behind the operator. Firing from an enclosed bunker or a small room meant risking severe burns or asphyxiation. It was a weapon that practically traded the life of the operator for the vehicle they targeted. If the operator survived the backblast and the approach, the beyond armor lethality was near absolute. When comparing the infantry arsenals of World War II, the Panzerfaust stands out as an absolute brute. While the American Bazooka or British Piat created small entry holes and carried moderate payloads, the Panzerfaust punched a massive 2.75-inch hole into the steel hull. Once inside, the hypervelocity jet introduced a devastating volume of high-pressure gases, molten copper, and violent sparling, which is shrapnel torn away from the tank's own interior armour. It instantly targeted electrical systems and ammo storage, resulting in a 48% casualty rate among the crew per penetration. It is no wonder it earned an extreme lethality rating. This terrifying lethality created an atmosphere of absolute paranoia for Allied tankers. Urban environments became nightmares, turning every basement window and pile of rubble into a potential source of catastrophic vehicle loss. Crews began improvising, piling sandbags, logs, and concrete onto their tanks to create spaced armor. Ironically, wartime testing showed this often backfired, actually optimizing the Panzerfaust standoff distance and giving the chemical jet more room to form coherently before hitting the main hull. But in the final months of the war, this weapon took on a dark, tragic role. Distributed for just 20 Reichsmarks each, the desperate Nazi regime handed these weapons to old men and children in the Volkssturm and Hitlerjugend. Sent into battle with as little as half a day of training, they were ordered to ambush advancing armour, a directive that resulted in staggering, pointless losses. The legacy of the Panzerfaust didn't end in 1945. During the Battle of Berlin, the Soviet Red Army quickly recognized its utility, capturing massive stocks to clear German pillboxes and fortresses. In fact, while Panzerfaust knocked out an astonishing 700 Soviet tanks during that final battle, Soviet sappers were simultaneously firing 200 to 250 captured units a day back at the defenders. When the war ended, the blueprints for the advanced reloadable Panzerfaust 250 fell into Soviet hands, heavily inspiring the iconic RPG-2. This transition introduced an interesting shift in physics. While the original Panzerfaust acted like a thrown football pushed off course by crosswinds, rocket-propelled systems like the RPG react counterintuitively, turning into the wind due to their tail fins. Ultimately, Dr. Langweiler anapos a core philosophy. A single-shot, disposable, chemically penetrating ordnance remains the gold standard for modern light anti-armor weapons today. From the American M72 LAW to the modern AT-4, it forever altered the geometry of war, proving that with a determined operator, armor is never truly invulnerable. Thanks you for watching. Please like and subscribe for more of these videos.